Right, this is lesson 6.5. We're talking about operations and radical expressions. I'm going to make this as simple as possible, and this is just a guide for you to understand what we're doing. So, operations. We have 4 operations in math. We have addition, subtraction, multiplication, division. We're going to learn the rules on how to do radical expressions with all 4 operations. So we need to know just basic radical rules, what it means to be simplified, and we need to know exponent rules. Those are going to come in play. If we don't know these things, then we're going to struggle with this lesson. Okay, so the first thing we need to know is let's start with the product rule and the quotient rule. So the product rule and the quotient rule, in order to multiply or divide radicals, you have to have the same index only. So for instance, if I had the product of A times the product of B, because they're both indexes or implied to, I can put them under one radical sign. So what does that mean? Let's look at this one. It will help us to simplify. Sometimes, so we know that 32 is the same thing as 2 to the 4th times 2 times x to the 4th raised to the square power. Okay, so let's look at this. We can rewrite this to say the square root of 2 to the 4th power times the square root of 2 times the square root of x to the 4th raised to the 2nd power, if we wanted to do it that way. We can say the square root I need to have, so the index is 2, 4 divided by 2, that's 2 square. This one cannot simplify, so I simply have square root of 2. And then here, I can take out 1, so x to the 4th, and this is 4x to the 4th square root of 2. All right, let's look at another one. If I wanted to do the 4th root of 16 times a to the 24th times b to the 13th, we're just working backwards from the product rule. So we're saying the index is 4, so we have 2 to the 4th times a to the 24th, and we can separate all these into, if it's easier to say I need to do the 4th root of that times the 4th root of that. So we said 4 divided by 4 is 1, so 2 to the 1st. 24 divided by 4 is a to the 6th. Here we can change this to say b to the 12th times b, because this is a multiple of 4, so that becomes b cubed square root of b. Now, even though we have an odd and an even index, we don't have to do the absolute value because you have another b in here, and b can't be negative or it would be undefined. So we have to assume it's the positive, so our answer is a to a to the 6th b third square root 4th root of b. Okay, so that's all you're doing. So this is just a product we're working backwards or showing how to simplify by breaking it down. So that's what the product rule tells you. The quotient rule tells you the same thing. You have to have the index. So if I have n a over b, I can break this down to say nth root of a over the nth root of b. Likewise, I can go from here to this. So it just depends on what the numbers are and which way you want to multiply this first. Now, we're going to learn the term rationalize. What does it mean to rationalize? That's when you have, for instance, a square root in the denominator. You cannot have a radical sign in the denominator, so you must rationalize it to get rid of that. And there's 2 ways. We're going to talk about this one way at the end of this section, which is conjugate. And the other way is going to be to multiply. Let's look at 416 here, at rationalizing. So look at this box here on 416. So if the denominator is square root of b, we multiply the numerator and the denominator by square root of b. Example, 2 square root of 3. We have this in the denominator, so we multiply both by square root of 3, and we simplify. If you have another number other than 2 as index, and b the x, you simply, in the denominator, you simply multiply by b to the n minus x. For instance, example, 5 over the cube root of 2. It's not square root, so we're going to multiply it by 3 minus what? 1. So we're going to get 2. So whatever 2 is to the first power, that's x. So 3 minus 1 is 2. So we're going to multiply the cube root of 2 squared, both the numerator and the denominator. Then in the denominator, we ended up with cube root of 2 cubed, which is 2. And then we end up with 5 cube root of 4. Okay, so that's what we do to rationalize. Let's look at an example. We'll go straight to the example of, we have the square root of x to the 6th over x to the 7th. So we can separate it like this. And 6 divided by 2, so imply 2, is x cubed. And then we end up with y cubed square root of y. That's a y, sorry. All right, let me make sure. I believe that's a y. Yes, it is. All right, so this is what we have. But we said in order for it to be simplified, we cannot have a radical sign. So this is n and x is 1. We're going to multiply by the square root of y to both. Remember, it's a fraction. What we do, we have to multiply by some form of 1. Then we get y squared, so then we end up with y cubed times y, because the square root of y squared is y, over x cubed times the square root of y, which is x cubed square root of y over x to the 4th. And this is where we have to know our product rule of exponents. 3 plus 1 is 4. This is a y, sorry. And there's your answer. So let's look at another one, a little bit more complicated. We have the 4th root of 6 over square root of 5. Over 5x. I personally like to separate it. Okay, this is 5 to the first, x to the first. I can't take it out because I don't have 4 of those factors. So I have to multiply what is n, 4, and each one is, so I have to, 4 minus 1 is 3, so 5 cubed times x cubed, and when I do the numerator, I must do to the denominator, 5 cubed x cubed. This way, when I take the 4th root of this, I end up with 5 x, because this can be written to 5 to the 4th, x to the 4th. And then here, I have the 4th root of 6 times 5 cubed, which is 6 times 125 times x cubed, because the product rule says as long as my index is the same, I can put all the radicands inside and multiply it. So this is what, 600, 725, so I have the 4th root of 725 x cubed. I can't simplify, I don't have enough to take out, but then I end up with 5x, because I need how many? 4 divided by 4 is 5 to the first, 4 divided by 4 is x to the first, and this is simply my answer. Okay, so I had to rationalize to get rid of this radical sign. So when is a radical expression simplified? Okay, it's simple when the radicand contains no factors other than 1 that are the nth power of the integer. So if I have 3 square and it's the cube root, I don't have any factors to take out. But if I have the square root of 2 to the 5th, that's not simplified, right? 2 to the 5th is the square root of 32. That is simply 2 to the 4th times 2. And that would be 2 squared times square root of 2, or 4 square root of 2 would be your answer. Now it's simplified because I had, even though 32 is not a perfect square, I did have some perfect square factors in there. Okay, there are no radicand, the radicand contains no fractions, and you can't have a radical sign. So you can't have this, or you can't have this, a radical sign in the denominator, because remember, this simplifies to this. I mean, you can rewrite this because of the quotient rule. So you cannot basically have a radical sign in the denominator. If all that's done, then it's simplified. Okay, and I said there's one more way to rationalize, and we're going to use its conjugate. Remember, we said the conjugate of x plus 1 is going to be what? Times x minus. The same thing with a different sign. Okay, we looked at that with complex numbers, 3 plus 2i. And we said to get rid of the I, we rationalize or multiply by its conjugate. And that got rid of the I. We do the same thing for radicals. So, for instance, let's look at an example for conjugates. So if I have a square root of b plus c square root of d, its conjugate is going to be a square root of b minus c square root of d. That's its conjugate. So let's look at an example where we have to use that with radicals. Okay, so that 1 is not under the radical sign. We have to simplify this. But they're not like terms. I can't multiply by just the square root of 5, right? Because it's tied together. I would still have a radical sign. I would get rid of this one, but then I'd put it over here when I distribute it. So I can't do that because it's more than one term. So what I need to do is I need to rationalize it. Multiply by the numerator and the denominator. Remember, it's still fraction rules. So square root of 5 plus 1, square root of 5 plus 1. When we multiply by its conjugate, so we have to distribute. So we have 2 square root of 5 plus 2. That's easy because it's just a monomial times a binomial. Here we FOIL. First times first, square root of 25 is 5. Inner times inner minus square root of 5. Last times last plus square root of 5. And then minus 1. Well, aren't these opposites? When you multiply the conjugate, the middle terms cancel out. So we have 5 minus 1, which is 4. So you have 2 square root of 5 plus 2 over 4. Now that is simplified. You can also write this as 2 square root of 5 over 4 plus 2 over 4. And this simplifies to square root of 5 plus 1 over 2. All right, so that's using conjugates. So you have to make sure you have to rationalize when you're multiplying or dividing radicals if you have a radical sign in the denominator. The next operation is addition and subtraction. Basically, they must be like. In order to add or subtract, the index and the radicand must be the same. For instance, let's look at some examples. Square root of 3b and 4 square root of 3b. My indexes are both implied 2. My radicands are both the same. Doesn't matter what's on outside. We look at the index and the radicand are the same, so they're like. Let's look at this next one, 3b and cube root of 3b. My radicands are the same, check. My indexes, whoopsie, they're not the same. This is an implied 2, so they're not like terms. I can't add or subtract these. All right, let's look at another one. Square root of 2b and the square root of 3b. Well, my indexes are both implied 2. That's a check, but guess what? My radicands have 2b. Even though I both have b's, they have to be exactly the same. They're not, so these are not like terms. So then how do we add or subtract? Let's look at an example. Okay, we said the index must be the same, yes. The radicand, no, but are they simplified? Well, you should know, let's see, 32 is what? 2 to the 4th times 2. So I can take out a 2 square, which is 4. 4 times 2 is 8, square root of 2. Let's look at 98. So we have to factor this. I don't know this one by heart. So we're going to do 2 times half of 98 is 45 plus 4, 49. So it's 2 times 7 times 7. So this is 7 squared. So I have 7 square root of 2 minus 8 square root of 2. So this is what this simplified to. Oh, my indexes are both 2. And guess what? My radicands are both 2. So now I do 7 minus 8. I simply add or subtract the coefficients. So that's going to be negative 1 or negative square root of 2. And you keep the radicand. And that's how you add and subtract them. So that is this section. Hopefully this helps you.